What's up, math fans? Take a look at number one here. I'm doing graphing vertical and horizontal lines. So if you look at number one, can you see these green dots? Give me the coordinates of any one of these green dots. It's hard to tell. Let me add one more. Let me add one right here. That looks like 4, 0. And this one looks like 4, 1 and 4, 2 and 4, 3. It's all 4 something. I didn't even put numbers. I didn't put any numbers on the y-axis because it doesn't matter. As long as I know it's 4 something, it's 4 negative something, 4 negative something, 4 negative something. So all of those points start with the number 4 and then whatever the y value is, which I don't really know. And I don't really care, and I'll tell you why. If I connect all the dots, pretend, assuming they go on to infinity, you connect the dots, meaning you have an infinite amount of dots. People, when they see a line, and I say, name a point there, they say, what point? There's no point there. Here's a line. I missed, but you get the idea. There's a vertical line. Going up and down is vertical. And I say, name a point here, and people are like, well, there's no point there. Yes, there are infinite amount of points. Just because you don't see giant dots jumping out at you, there's still infinite amount of points. That's actually how they used to do artwork in newspapers. I wonder if they still do that. You see a drawing, but if you get really close to it, it's actually just a lot of points, close together. So you see, it looks like a picture, but it's actually just lots and lots and lots of dots. So that's what a line is. It's an infinite amount of dots connected. That's a smiley face, or it was supposed to be. Okay, so keep in mind important points of this, important facts. This green line is a vertical line. And how I know I'm graphing a vertical line is the x coordinate does not change. The y coordinate is changing. Positive, it's negative, it's fractions, it's up close to infinity, close to negative infinity. But the x always stays the same. X is always 4 on this green line. So to recognize a vertical line, it's always x equals some constant, some number. I'll call it constant a. So this is specific for this graph, and this is the general case. If you see a vertical line, you're thinking x. All right? And by that logic, if you see a horizontal line, you should be thinking, what? You don't know? All right, take a look. Take a look, take a look. What's this point? What are these points? This is, I don't know, 1, 5, 2, 5, something, 5, negative something, 5. So here, on this line, if I were to connect all those infinite amount of green dots, I would get a horizontal line, and it's always something, 5. So for a horizontal line, in this case, what do you know? You don't know the x, but you do know for sure that y is 5. So for a horizontal line, it's y that's the constant. Horizontal line, y is the constant, and y is equal to what? What is y equal to? Some constant, I don't know, just pick b. All right, so that's the general case for horizontal lines. This is the general case for vertical lines, and that's pretty much it. If you got it, you're good. You want to practice? Try this one. Number 3, graph x equals 5 and y equals -2. I'll wait. Do it. So I'm going to sketch it, and I'm going to do it as quick as I can. So let me see your horizontal axis. I apologize for this video. It's I think it's zoomed in too much. You see my nose hairs. Try not to look. Okay, x, y, origin. I want to do x equals 5, so I'll do that one in green. X equals. I just learned that x equals is the vertical one, right? How you know that is find one spot where x equals 5. This is the x-axis, 1, 2, 3, 4, 5. Find 5, put a dot there. If x equals 5 here, it must equal 5 up here and down here also. Oh yeah, it's vertical. I remember. And that's it. Pretty simple. Hopefully you can see orange. I'll do this one in orange. Y equals -2. So, look it up. y equals -2. Let's see. This is the y-axis. -2 is here, so this is where y equals -2. Where else does y equal -2? Over here, and a million other places. So that one looks like this. And now you're an expert at graphing vertical and horizontal lines. And just for fun, I wanted to throw in this. What would the solution of this be? Do you remember what a solution is? How to find a solution graphically? You graph two lines, you find where they intersect, and that is your solution. So, look where the orange line and the green line intersect. This guy is your solution. Just tell me the coordinates. Oh man, I wish I used graph paper, it would be so clear. This was 5, this was -2. Oh, it's 5, -2. So in this specific case, the question was the answer. And that's graphing vertical and horizontal lines. Thanks for watching. See ya.